Gators, this is 6.8, Finding Antiderivatives and Indefinite Integrals, Basic Rules and Notation. Let's take a look at the derivative notation. This is a derivative notation and this is a derivative notation. Let's look at what we call a differential. A differential is the change in either the x or the y along the tangent line. So over here we can see that this is the change in y along the tangent line versus the change in y, which is delta y, along the function. The differential x and change in x will be the same. That will be same regardless of whether it's on the tangent line or on the function. Let's take a look at how we use differentials. Very similar to the way we use derivatives. So to find the differential y, we will take the derivative using the product rule and then times by dx, and that will represent differential y. Let's take a look at finding differential y in this case. Differential y, and what we want to do is take the derivative of this and then at the end times it by dx. So this will be 1 over tangent of 5x times secant squared of 5x, and then we want to times it by 5, the inner, and then at the very end times by dx. So this is how you find a differential. Now let's go ahead and find an antiderivative. Let's go in the opposite direction. Suppose we're given the differential. Can we get back to what we originally came from? And so that will be a y equals, and then what must we have come from? Probably a tangent x. And there's our answer right there. That's an antiderivative. Let's check our work. To check our work, we would find the differential, dy, take the derivative of this, which is secant squared x, and don't forget to put the dx right here. So notice that they do match, so we must have got the right answer. Solving this one, y is equal to 5x. This would be an antiderivative. That would work, and we could check our work to see if we do get that right, the same differential. Over here, y is equal to, I know I'm going to go up a power because when I take derivatives with powers, I'm going to go up a power. And when I'm thinking about 4 times what will equal 20, I'm going to use the number 5. So when I check my work, I'm going to find the differential. I'm going to use the power rule, which is 20x to the 3rd power, and then don't forget to multiply by the dx. And those match, so I must have found the right function here. Let's go ahead and find derivatives of each of these functions. So the derivative here will be equal to 2x. Over here, the derivative will be equal to 2x. And the derivative over here will be equal to 2x. So in each one of these, the derivative is 2x. The only thing that's different is that each one of these functions has a different constant that's being added or subtracted to it. So if we want to find the whole family of antiderivatives, we will write it this way. This is the general solution. And if you know enough about the function and the point, this is what we call a particular solution, because it's only one in the whole family. We must have had more information on that. Let's take a look at this graphically. So if our derivative is 2x, and here is the line 2x, that represents the derivative. And this is telling me the slope before 0 is negative, the slope at 0 is 0, and the slope after 0 is positive. And each one of these parabolas, and here are all of the possibilities, are possibilities for a particular solution. This is regarded as the general solution, because it represents what all of the family looks like. All right, so antiderivatives and indefinite integrals are one and the same thing. They mean the same thing. So an indefinite integral of f of x dx, that's what this is right here. An integral of f of x dx is a function, so it represents a function whose derivative of f of x. So if I were to find this derivative of this, I would get back to what I started with. Verbally, we say the integral of f of x with respect to x. The indefinite integral is the same as the antiderivative. This symbol is what we call an operator. It tells us what we're about to do, just like a cosine does, a minus sign, a square root sign, a square sign, all of that. Okay, so these are equivalent expressions. The derivative of this antiderivative is the function. The derivative of this is, again, the symbol for antiderivative. So when you take the derivative of the antiderivative, you get back to the function again. All right, let's take a look at f of x equal to 3x squared. Its derivative is 6x. The expression 3x is one of the many of the antiderivatives possible. It is an antiderivative. Let's take a look at undoing the power rule. But first, let's look at the power rule. When we have a power, what we do is we multiply by the old exponent and subtract 1 from the exponent. So this is how we find a derivative. The antiderivative process is in reverse. So what we're going to do is we're going to add 1 to the exponent. And then what we're going to do is we're going to divide by the new exponent. So in this case, we're going to do x. We're going to go up a power, and then we're going to divide by that same new power. And if we want the whole family, we'll write plus c. Let's take a look at finding the antiderivative of all these. Okay, an antiderivative of f of x. So now I want to call it capital F of x. I don't want to call it f of x because I want these two symbols to look different. And so the rule is to add a power and then divide by that new power. And this will be the antiderivative. If I were to take the derivative of this, I should be able to get back to here. Now let's take a look at the other two by rewriting them just a bit and writing them as powers. And so I want to find the antiderivative, which is capital F of x. I want to make it look different from this symbol. And I'm going to do 5x, and I'm going to up the power and then divide by that same power, plus 6x, and the up a power, which is minus 2, and divide by the new power, negative 2. And then this is minus x, and then plus c to represent the whole family. Over here, the antiderivative, capital F of x, to be different from lowercase f of x, will be x to add a power, 3 over 2, and divide by that same power, 3 halves, plus 3x up the power, and so that'll be 1/2, and then divide by that same power, 1/2, plus c. Now, if you can get comfortable, maybe you can go to this step right away. When you divide by a fraction, remember, it's like multiplying by the reciprocal, x to the 3 halves plus 6x to the 1/2 plus c. So some are able to go from here to here. Some need that middle step. All right, let's take a look at undoing e to the x. This is asking us to find the antiderivative. And the antiderivative will be e to the x plus c. Now, how do I know? Well, because when I take this derivative, I'm going to get back to this. As far as this one is, it's going to be itself. But unfortunately, when we take the derivative of a to the x, the answer is a to the x natural log of a. So we have a multiplier. So what I will have to do is I'll have to divide by that multiplier and then plus c. And if I were to take the derivative of this, I would get back to this. Okay, so let's find the general solution. And the general solution is itself divided by the natural log of 7 plus c. And so that will be the general solution. Now let's go ahead and find the particular solution. So let's find the general first, f of x. So the antiderivative of f prime of x is f of x, and it'll be e to the x. And then I'm going to use my power rule, minus 2x to the up the power, 3 divided by 3 plus c. All right, now I have a value here. I know that when x is 0, y is 4. So my y is 4, and then this is e to the 0 minus 2 times 0 cubed over 3 plus c. and I can see that this is going to be 4 equals 1 plus c. Therefore, c is equal to 3. So now I can rewrite my function. It'll be f of x equal e to the x minus 2x cubed over 3 plus 3. Now this is the one solution that has this point in it. Let's take a look at the derivative of natural log of x. The derivative of natural log of x is 1 over x. Now remember the requirements of this. Natural log of x, x has to be positive. If you remember what the graph looks like, here's the graph of natural log of x right here. And remember that the domain does not have any values that are less than or equal to 0. So this is, if we undo it, this is going to be the natural log of x, but in order to assure that x has to be positive values, we put an absolute value sign. So this is what we have here. All right, so how will we find these? Now remember, you just take each one in parts. The derivative of 1 is x. The derivative of this is minus 5, and we have just figured out that this will be the natural log of absolute value of x plus c. So that's what this is equal to. This antiderivative is equal to this. Let's find a particular solution. We might want to write it this way. Now this is 2 over x, but this is a power rule here. This is 6x to the negative 2 power. So f of x will be equal to 2 natural log of absolute value of x plus 6x, and add 1 and then divide by that same power plus c. Now we know that when x is 1, y is negative 7. So this will be negative 7 equals 2 natural log of 1 plus, this is going to be negative 6. And if I put a 1 in here, that's over 1 plus c. Okay, now we know natural log of 1 is 0, so this is a 0. And if I add 6 to both sides, I get negative 1 is equal to c. So now I have my solution, my particular solution, and that'll be 2 natural log of absolute value of x minus 6, and I'm going to put the x in the denominator, and then we know this is minus 1 because we figured out that c was negative 1. All right, here are the trig integrals. Let's see, let's go to the next page so you can see the answers. So these are all the antiderivatives, and you can check your work by finding the derivative of each one of these. You should be able to get back to this others. So for number 5, the answer, the antiderivative will be, now this is just a constant, so that'll just be a 3, and secant squared, that's going to be tan x plus c. And then for this particular solution, we can say f of x equals x, and then this is going to be plus cosine of x, because the derivative of cosine x is negative x plus c. All right, and then I'm going to put pi minus 2, that's my y value, and then my x is pi plus cosine of pi plus c. Now remember, pi, cosine of pi is negative 1, so c is going to be, the pi's are going to go away, and this is a negative 1, so this will end up being adding 1 to both sides, so this is going to be negative 1, and then that's what this value will be. So f of x will be equal to x plus cosine x minus 1, and that will be the particular solution. Let's take a look at inverse trig derivatives. Do you remember what these derivatives are? Here they are. And so if you recognize them, then you'll be able to find the antiderivative here easily. It'll be sine inverse x plus c. And then this will be easily found, and it is secant inverse x plus c. Separating rational functions. Sometimes these look impossible, but they can be possible if you'll just separate them, and then you'll be able to actually do power rules on each one of them to be able to do that. Let's take a look at when we are given a second derivative and information about the first derivative and the function. If I have a second derivative, I can actually find the first derivative by finding the antiderivative with my power rules. And then I simplified here. And then I used what I knew up here. I knew that f prime of 4 was 2, and I found that c was equal to 3. So at this point, I've done it once. I have the derivative. And to find the antiderivative here, this would be f of x. And then I'm going to go up a power again. So up a power will be 1/2, and then you divide by that 1/2 plus 3x plus c. So I'm going to use this as my condition here. Y is 0. And this will be simplified to -4. And then this is root 0 plus 3 times 0 plus c. So it looks like c ends up being 0. And so my solving for my f of x will be, let's just make that look nicer, -4 root x plus 3x. And I don't have to write a plus c because I know it's 0. And this is the end of the screencast.